What the heck?
Is that you? Yes, it's me! Yes, it's me! Prove it! Prove it! I asked you first! I asked you first! Yo-lo-lo, pee-pee! Yo-lo-lo, hoo-hoo! Yo-lo-lo, li-lo-li-li-lo-lo.
Another interesting aspect of space travel is that it's not possible because thrust and combustion are not viable in a vacuum. Let's review a couple of experiments in a vacuum chamber that prove what I am talking about. First experiment, thrust in a vacuum.
You can see when I turn the fan on, it blows the feather all over the place. This is, of course, at atmospheric pressure right now. So since we're at Martian air pressure, let's unplug the vacuum pump and let's turn on this fan. And place your bets as to what's going to happen to this feather. Now the fan's only going to produce maybe 10 miles per hour worth of wind. On the surface of Mars, the fastest recorded wind speed is about 70 miles an hour. But let's say the superstorm in the Martian had wind speeds of 200 miles an hour, 20 times what we have here. To compensate for that, I imagine the feather is about 20 times easier to push over than a spaceship. So let's see what happens. Okay, fans on. And the feather's not moving. In fact, let's zoom in on that.
Thrust does not work in a vacuum, and thrust would be needed to traverse outer space. Second experiment, combustion in a vacuum.
This is a mixture of sugar, potassium nitrate, and iron oxide. This is used in amateur rockets because the ingredients are readily available and the amount of thrust it produces is quite high. So let's light this on fire and see how it does. So this is in Earth atmosphere. As you can see, it burns rather rapidly, producing a little bit of thrust even. As you can see towards the end, it moved it around. So now let's try it inside of a vacuum. No ignition. That's interesting.
Combustion does not work in a vacuum. This is a very big deal. Space travel falls on its face and breaks it, then dies with these two vacuum chamber experiments. Thanks, Cody's Lab.